Hello, this is a tutorial on how to use DTIA Decision Tree Insights Analytics or Decision Tree Insights Analyzer Python package to extract insights from large data sets using decision tree classification method. So after installing the package using the README file on GitHub, then first you create just a normal Python file like this one, and then you import pandas, the analyzer itself, DTIA itself, and then you start reading the data. So here we read the data from the file. This example is on the iris dataset. So we had 4 features. Those are the 4 columns. And then we had the labels. It's a multi-class problem as shown in this CSV file. So we have sepal length, sepal width, petal length, and petal width as features. And then we have 3 labels, 0, 1, and 2. After that, after extracting these data frames using pandas, you extract the values in terms of X and Y. Then you start adjusting the parameters of the DTIA itself. So the first parameter here is the test percent. How much would you like to have test and training percentage? So here we use 20% test. And then here we have 3 parameters with regard to the 2 parameters with regard to the minimum number of samples per leaf in the decision tree classifier itself. So it tries minimum number of samples per leaf from 1 to 10 with increment of 1. So it tries a model with 1, 2, 3, 4, 5, 6 until 10. And max depth is the same thing. It tries from 1 to 5. Those parameters are user specified depending on the problem and the volume of the data set itself. And here is the number of folds for the cross-validation process. So in order to make sure that the developed models from where we are extracting the insights is robust, we need to cross-validate it. So here we're taking 10 folds cross-validation. Then to make sure that the models are not overfitting, here's a metrics diff. Metrics diff is the difference between the test precision and the training precision. And it's also problem specified. Like here we used 5% metrics diff between the test precision and the training precision. After that, to make sure that the model actually trained on the data and not just like, you can have something about 45% precision and 50% precision. The metrics diff will remain 0.05. But to make sure that it actually performed well, so we calculated the average test metrics. And here's for the selection criteria, the average test metrics is 0.95, which is 95%. The average test metrics is the average over 4 different classification metrics scores, which are accuracy, precision, recall, and F1 scores. Then here, these 4 variables are for how to store the analytics or how to store the insights extracted from these models. So the first one here is model metrics out path is the place where it will provide a CSV file with all the required data, like all the models and their metrics in the training and precision. Also their parameters here, how many minimum number of samples per leaf were used, what was the max depth, and which fold number was used to be used later if you would like to go to in-depth analysis of a certain model. And here is the model details out path. This place records, or this is where we store a CSV file for each decision tree model developed in this process. And you can actually see the number of samples per node and each rule extracted, how did it affect the different data split. And then here's the important node file path. This is a file that includes the IDs of the different important nodes. Important nodes which are extracted later in the node ID feature threshold, which is the file that has a summary of the insights that you have, like when you split the trees and started comparison for each location, what was the feature used and what was the corresponding threshold. And now we will see an on-hand example for the iris dataset and how to use the results. So this is just an Anaconda prompt PowerShell, a usual Anaconda. I've installed it earlier, the DTIA tool. And now I'll be running this file. See, this 10 is the minimum number of samples per leaf that it tried. So now it's done already because the iris dataset is really small. And then after that, we can go for the results. You can see here DTIA analysis results. And these job libs are the models that are created, aren't selected. Some of them are performing poorly, some of them are performing good. But as you can see here, you can find there is a code for each model. DT is just decision tree. 9 is the minimum number of samples per leaf, and 5 is the depth, and 2, 3, 4, 6 is the number of folds. So here you can see the performance of each model, as we spoke about earlier. So you can see here, first of all, this is the diagraph that has been used for extracting the insights and how to plot. You can plot this with GraphWiz or anything to plot the tree itself. And then here's the fold number. Let me just expand these a little bit. So we can see here the minimum number of samples per leaf, depth, and the fold number here. So these are there. We put those parameters there to be a guide when you would like to see a performance of a specific model. And then you have training precision, training accuracy, training F1, and training recall, and test precision, accuracy, F1, and recall. The reason I'm showing you this because this will act as a map. So to how you can access a certain model with a certain performance. For instance, if you'd like to see the model that actually in the test, it outperformed the training. Here it had 100% and here it had like 95, 96% in the training. So you can actually go to these parameters, 713. The fold number is 7. The minimum number of samples per leaf was 1, and the maximum depth was 3. Then you can go here for the model details and see here, cross-check this against the details of the model itself. So it was 713. So minimum number of samples per leaf was 1. And the depth was 3, and the fold was 7. So here's 713 fold 7, depth 3, minimum number of samples per leaf was 1. And then you can just open it and see that at node 0, which is the root node, you had 120 samples, 38 in the first class, 42 in the second class, and 40 in the third class. This node used feature 2, which is in the iris dataset, 0, 1, and 2, the petal length. And then the result of this, you have 0, 1, and 0, 2. So at 0, 1, the petal length on its own, it discarded 2 classes, was less than, those 2 classes had a petal length higher than those 38. So it's a pure leaf here. So it's now, this is only class 0. Class 1, class 2 did not go this direction because they had a petal length higher than the threshold. And then from 0 to, it needed a further rule, used the petal length again. And then from 0 to 3, it needed another rule. And then from 3, you ended up with 2 leaves, nodes 4 and 5. So this is how you can read this details of the decision, one of the decision tree models that has been developed. So to see further details, you can see that number of samples for class 0, number of samples for class 1, number of samples for class 2, if you'd like to extract it and automate the process of the post-processing, or if you'd like to see a specific thing. And then you have the node path itself for each level. So you can see here that node path 0, 0 leads to 1, and 0 leads to 2 as well. But 2 leads to 3, and then 2 leads to, when 2 leads to 3, 3 leads to 4 or 5. So it's 0, 2, 3, 4, 5. So if you'd like to see how did we get to this particular leaf, you can actually walk down the path itself and see how did it go. So these are the node IDs that lead to a certain leaf. That's how you check the different details from different models. And then after that, you have the summary of the insights extracted. The summary of the insights extracted can be found here in the node ID feature threshold file. As we can see here, you have node ID path 0, path 0, path 0, and then path 1, 0, node ID path 1, 0, and feature path 1, 0, and threshold path 1, 0. For each node ID path with a number, it has a feature column and a threshold column. So here we can see that for the path 0 is the root node. It used feature 3 or feature 2, some of them. Some of them were feature 3, some of them were feature 2. So to provide further analytics, you can actually use the Excel to count, like you can see, do a unique function. You can do it with Excel, with R, with MATLAB, whatever you have. You have a CSV file that you can use anything basically in it. So in the column C, you can see here that it used 3 different, sorry, let's copy its values. It had 3 different, oh no, the zero is not there. It's just because I used from C to C. Let's make it more accurate, C2 to C end, which is 2 to 2. So it only used features 3 and 2. Then after that, in this particular node, after that, you can actually count how many times did it use feature 3 or feature 2. Count if C2 to C22, and the criteria is, let's make it that. So it used feature 3 8 times, and it used feature 2 13 times. This is not right, actually. Oh, sorry. 222. Yes. Okay, it's 222 as well. So it used feature 3 107 times, and it used feature 2 114 times. The total number of models here, each one of these models represents a decision tree that actually has been developed and passed the selection criteria that we mentioned earlier, that we set earlier in our Python code. And then after that, you can check the second node, which is feature node ID path 0, but it does not have feature or a threshold. The reason behind that it does not have feature or a threshold is that it was a leaf. So there is no rule there to extract to do any further splitting. And then you have the node ID feature, node ID path 11, which were the samples that did not follow the first rule, which did not follow, was not less than the false of the first rule in the root node. It went into the path 11. 1-0 is the true path, 1-1 is the false path. So here you can see that it used features 3 and 2 as well. Most of them. You can perform the same process of analysis on that, and also you can calculate the average maybe of the thresholds, or see the impact of a certain threshold on this. So I hope this tutorial can clarify how you can use DTIA for extracting data analytics and extracting insights, physical or biological insights across datasets. In reference to how the method actually works, I would like to invite you to read the paper cited in the GitHub when it's published. Thank you.